DevOps and David here with a new video, and today I'll be I guess I look a little bit like Steve Jobs, so let's say I'm Steve Jobs of servers. Right now, no, I'm kidding. Today this video will be like absolute cheapskate hardware guide, how to get the most bang for your buck. And the context is like, if today, with all the knowledge that I've accumulated, if I want to do a startup and I want to spend the least possible money to get my hardware up and running, what would I do? So this is the video, right? So these are like my opinions, and this is like an entirely holistic view. This works together with everything that we've discussed so far, right? So everything is connected. I don't think you can usually optimize a system like you optimize one part really, really well and then you don't need to do anything else. Usually when you optimize things, you need to optimize things whole. Like any part can affect any other part. And I think this is the same way with buying hardware and everything. So, as I mentioned already quite a few times, I prefer bare metals. And there's this, everyone today wants to go to the cloud. I don't know why, but people want to go to the cloud. I think, there's like this teaching, it's fast, it's convenient. People don't know anything to say, like, cloud is convenient, go to the cloud. And I guess these people, like, they never opened two spreadsheets and compare the costs, right? But, I guess, people just like opening Terraform and creating everything in all different regions and everything theoretically works. But I don't think cloud machines are that reliable. I think they're much worse from what I tried personally. I recently, I got a project where I needed to deploy some stuff for a client, and the options was, okay, we have like either this infra, bare metals, or there is a cloud, like a popular cloud choice everybody knows about. And we went with the cloud because, it had to be in a different region, whatever, the reasons don't matter. But I started deploying there, and I cannot believe this. I deployed an instance of a service and it was running out of memory, but the process is not killed, but the entire virtual machine stops working. It just halts, you need to restart, and then it doesn't work again, like after some time, right? You add more memory, then okay, it works. But what I'm saying is, in a virtual machine, if your process runs out of memory, your virtual machine shouldn't stop. It should just keep on going. It should just kill the process that exhausts the memory. And there the entire machine becomes unresponsive. And I'm like, I was thinking that, I saw that, who would use that? And of course, IOPS was 20 times less than what we had on bare metals. It was an absolute disaster, right? So anyway, now that I ranted about clouds, and if you want to pick a cloud and you're still we want to go to the cloud, yeah, that's your choice. I would just give one advice. If you pick a cloud, at least pick a service. I recommend picking a cloud where the only service that is provided by the company is the cloud. Like, that's it. They provide cloud and nothing else. For instance, I had good experiences with DigitalOcean. Other services, company might be doing 1,000 different things, and one of them is a cloud. And guess what? The service is an absolute trash and works horribly, right? Because they're selling their leftover hardware space, so nobody cares about you. As opposed to a service that specializes in the cloud, right? So that would be my 2 cents. If you want to go with cloud, I'd recommend something like DigitalOcean, where they only do the cloud, right? So, okay, now that I ranted about cloud, so the cheapest way will always be, I think, when renting servers, you don't rent just a dedicated server, because these cost quite a lot. Bare metals cost a lot when renting them. So what I suggest is just buying colocation, which means you buy a rack space and you can then buy your own server, and then you deploy that server in a data center that has internet, it has electricity, it has ventilation, right? And it has admins that can replace disks and everything, right? But you own the hardware. So this way you might need to pay only 70 or $100 once you're starting out monthly. right? And well, in AVS you get like, I don't know what, I didn't deploy there for a while, but you don't get beefiest machines for $70, right? So if you own the hardware, so of course we'll talk about buying some hardware. And well, for this video I was browsing like bargain hardware, right? And I just selected a setup, like hypothetically, what would I do? And you can get a monster 44 Intel CPU server, and it's 88 threads. And it's like the funny thing, once I measured like the difference between the real cores and the threads, you know, that like core that has 2 threads with hyper-threading. And actually I measured, at least in my experiment, that the threads are as equal as cores, right? Like 90% there, so you have like twice the cores, right? So I started respecting threads after that experiment. So anyway, you have like 44 CPU, but 88 thread machine, so you have like 88 cores here. You have only, I select, we're starting out, remember, I want to spend as little as possible. I could fill this up with 3 terabytes of RAM, right? So in the beginning, we don't need that much. I just selected 2 64 gigabyte RAM sticks, and that machine is already monster, 128 gigs of RAM. Huge, right? And I selected 2 4 terabyte SSD disks. The biggest disk, but only 2, and there are 12 slots still in the machine. The logic is, and do I talk about scaling? Oh yeah, I'll talk later about scaling, but this will be important later, because if you have like 4 terabyte disks, you can have more, and then your disk space doubles, and you can do this even online. Your disk space doubles, and your IOPS also double, because we're running RAID 1.0, the most performant IOPS setup, right? So in this entire absolute monster machine, even though it's just, we selected only 2 sticks of RAM, 2 SSD disks, it only costs around 1,500 USD. And you buy this once, you own it forever, or you can, you know, if your startup fails, and most of them will, right? Then you can even sell this hardware and reclaim all most of that cost also. So for 1,500, right? So I went to a popular cloud vendor and I checked like how much would this machine with similar specs would cost if I just, you know, got it from the cloud, right? And you're paying for it monthly. So monthly this costs around more than $2,000. So if you're running your startup more than a month, you're already in profit with this server. Can you imagine like this? You buy it once, you don't pay it, you have this monster machine and you just pay for electricity and network bandwidth, right? So I think that the cost is huge, and I think people who flock to these, oh, you know, we want to get like to the cloud, you know, it's convenient, if they just, guys, just put in a spreadsheet the hardware costs that you're paying, right? Because like if you run a startup, you know, there's this, oh, we want a quick open in another region, but if you open in another region, usually keep running on the same region. You don't need to like, do you have a need like on demand? Oh, one night I'm in this region, one night I'm in that region. No, if you like, usually if you find a setup that's running, you just stay there, you run there, and you're like pretty much static if you're not scaling in that region, right? Or you scale a little bit, you add a little more machines, but you know, you usually infrastructure, once it's running, in my experience, it doesn't change that much, and paying for that convenience, like doing this, that, well, you might like test with more, you know, like you might run some hardware test, like simulate entire infrastructure, but you can do this as well. You have beefy machines, you can create VMs inside this machine as well. And I had this, like, I simulated, I was working in an environment, I had to create an entire environment, and I said, okay, give me one beefy bare metal, I'll split it off in a lot of VMs, and we tested the entire infrastructure of like 16 virtual machines, and I developed all the entire infrastructure just on that, on single bare metal, on all these virtual machines. And when the real bare metals came, everything was just working. I just deployed as is. But I was developing, running experiments just on single bare metal. So you don't even really need to think about that. Just raise huge infrastructure and then pay a lot of cost, and then we can simulate experience. You can do this as well with bare metals, because every single thing that you rent on a cloud is running on a bare metal, probably as a virtual machine already, right? So I think I don't like cloud, if you can't see, if you can't tell already, right? So anyway, I got carried away a little bit there. So another point is CPU. Why do we buy used servers? Because there's other extreme point, like where people want to buy brand new servers, the latest and greatest bare metal. You're gonna pay a lot of bang for those servers. You're gonna pay I saw the invoice. Of course, I wasn't paying the invoice. It was the company, but I saw it's insane. It's crazy. Like, you could get 10x bare metals, like few generations older. But when I say, it's old software, I'm just saying CPUs and disk IOPS, they don't really advance that much, right? And for instance, disks you can replace to be the latest, greatest model, even if you have an old server, right? All CPUs you can replace, it depends on motherboard socket, right? But even today, like CPU cores are usually capped at 2.2 gigahertz, right? As I watched the Intel servers. Are new epics faster? Yeah, they're a little bit faster. Are they that much faster so that you should pay like 10x if you want brand new servers? I don't know. So of course, this server, that bargain hardware that is now 1,500, it probably costed like, I don't know, I'm just guessing $20K, $15K dollars when it was brand new. So if you just buy older server, you have like, say, 70 or 80% CPU capacity of old. You have less cores, right? But single core is still very capable. You have also good enterprise disks that you can add into old server. And you have DDR4 RAM, right? And you can add a lot of that RAM. So is this server really that disadvantageous against the new server? So yeah, so you pay for this only 1,500 and you have it, right? So that's like, I think it's a great way to save money, right? So another thing, of course, ECC is a must, and usually all servers these days, little older ones, they have ECC RAM. If you don't have ECC RAM, then you might have like process corruptions and everything, errors that you can't predict. It's like having just, disk, but you don't have any RAID, and if you corrupt that disk, then whatever happens. You don't have checksuming, you are unaware. Bad deal, right? So you should have ECC RAM. Of course, the server has ECC RAM. So, and I'm just mentioning this because all servers today have it. I'm just throwing this in there. And the objection I've heard against old used servers is, new servers, like you have warranty and they run better in general, right? So yeah, I agree. Like, new car runs better, and old servers, they break down more often than the new servers. But which is the part that breaks down in a server? It's usually not CPU. It's usually not RAM. It usually breaks down. The hard disks break down. And since we're running ZFS, we're using a spare disk so that, if a disk fails, it's automatically replaced. Applications aren't even aware of the disk failure, right? So this most common part is taken out. And another thing, if you go into the meeting and, you had suffered downtime and you say as the manager, we suffered downtime because we were running old servers. Like, I heard this excuse, right? First of all, if one server goes down and your infrastructure is down, that's a poorly architected infrastructure. You should be highly available, right? So if you run Postgres, you should not be running on one server, but with Patroni. And if you're running queues like Nets, you should run on multiple servers. Like same with web servers, or that serving front end app, you should have many of them, right? So if one server is down and your infrastructure is down, you screwed up, right? So I don't think it's a valid excuse for why you shouldn't want to save like this much on hardware, right? So let's talk about scaling. So as I mentioned already, this is in bargain hardware, this is minimally equipped server. Like there are up to 3 terabytes of RAM. I added only 128 gigs, 2 sticks of 64 gigs of RAM. And I added only 2 SSD disks out of 12 slots. Why? Because just to save money. Because we don't need all that space in a startup. We don't need all that. It will be underutilized for a very long time, right? And if we do get a needs for scaling, right? If we do actually see that, okay, we should have more RAM, we should have more space, right? So what do? We simply have RAID 1.0 running on ZFS, and we can add another pair of VDEV of disks. So we add another pair of disks. That's another 4 terabytes of storage. And 2 times more IOPS, 2 times read IOPS and 4 times read IOPS and 2 times write IOPS. But anyway, so you can add like this pairwise little by little scaling. So okay, RAID 1.0, you add another VDEV of 2 disks, a mirror, and you have twice the space and twice the write IOPS, right? And you can go this until you fill the same slot. So you can add another VDEV in ZFS, and it doesn't even need to be offline, right? And it will start distributing writes to the disk that is now empty, right? And it will eventually balance out. And then you add another pair, more 4 terabytes, another pair, until you fill all the 12 slots. Or I would fill like 10 slots and keep like 2 spares, And the same with RAM. Well, you'll need to have a restart machine with RAM, but you're highly available, so we could buy 3 servers. 3 servers from the start, pay $4,500, and then we can just shut down one server, add 2 sticks of RAM, reboot it, all the services distribute again, everything's working again. We do the same, we circle around, we add RAM to all machines, and we're up and running again. So we should be good. So we added the minimal setup, spend very little money. We have monster server, and we can scale disk space and we can scale RAM with ZFS. Like we don't need to, it's so good that we're running ZFS, we don't need to repartition volumes, because other file systems, you just choose it once and that's it. You can't do anything else. Here with ZFS, we can add pair by pair more disks. It will distribute itself evenly eventually, and we can just grow like that. So I think everything works really great together. Like ZFS, bare metals, adding this, everything. Cheap stuff, redundancy when you replace pairs, applications unaware about failure. So I think everything works quite well together here, right? So we speak about hardware part, right? So now let's talk about software. So how do we use these bare metals most efficiently? And my tips that I can give you is to, first practical tip, avoid JVM stuff. So in the industry, there are lots of stuff done with JVM. Like for instance, there is Kafka for message processing. It doesn't use too much memory, but these days I use NAS, right? And it's Golang based and it's very lightweight. You don't need much memory to use it. It doesn't use CPU, right? It's very lightweight. So you just use this and you can run a lot more stuff. Or there's, if you need a big data stack, say, I hate that keyword. So say there's Hadoop, right? You can run HDFS stuff, all the Apache Spark for all the crazy computations that will consume all your all your RAM, all your disk space and everything. Or you could have a much more lightweight alternative of ClickHouse, which doesn't use that much memory. You can configure exactly how much it uses, and this is written in C++, so it's much more nimble, it's much more lightweight, right? But it does compute results a lot faster, right? Or there's Rails consumes quite a lot of CPU. So for instance, I worked in a company once and it was like, I couldn't believe it. Like there's my SQL instance that's hammered like few thousand transactions per second, right? And it's just one instance and it's handling all the work that Rails app is giving to it just fine. It's handling, it's changing the data, it's appending to route ahead logs, it's refreshing it, it's everything. The MySQL instance is working just fine. Guess how many web apps are there that run Rails instance? There are like, I don't know, there were, last time I saw it, there were 100 of bare metals running Rails apps. 100 bare metals. Can you imagine that? 100 bare metals just hitting one MySQL shard. Well, there are more shards, but there were many bare metals, and these are filled with Rails processes, and that's all that these servers do. And I'm like, wow, what a waste of hardware, right? So that's why, I prefer writing my websites or something that I need. If you write it in Rust, it doesn't use memory and it uses very little CPU. And you can serve a ton of requests, and your web servers are mainly idle. You can serve crazy. Go is similar, but Go does have garbage collection, so it does have garbage collection latency. I think it's second, but Go processes are also quite lightweight. I just don't like when there are real-time systems that, if you have garbage collection, you will have garbage collection pauses, and there's not too much you can do about it. With Rust, if you write something in Rust, then you just don't have garbage collection pauses, and you have real-time system, and you're done with your day, right? So this is how I would like to see how infrastructure would look. That would, if you use the Rust, the nets for queues, like Postgres for database, and ClickHouse for data archiving. How would the setup look that would use all this hardware, like three highly available servers like that, like 88 logical cores, 128 gigs of RAM, and 4 TB disks. So yeah, so you can get done a lot with this, right? You probably can serve. You will at least find out with this initial investment of 3 servers with 1,500 if your startup idea will fail or not, right? You will at least get there where you get some users, and then you might need, we might need to start vertically scaling or adding more servers or something, right? So yeah, so I already mentioned this lightweight stack, Rust or Golang for your web application, and don't be like, we have 3 bare metals, so we want everything that we have will need to be scheduled on those 3 bare metals. So all the services that you need run on these 3 bare metals, and there is a lot of multi-tenancy for you. So this is efficient use of hardware, but sometimes you might need, if some application exhausts disk IOPS or something, you might need to check there, do something about it, right? But of course, the main thing here is we're cheapskate. We're very cheap, and we should utilize all this bare metal hardware efficiently. We're not running in a VM, we're running in a bare metal, right? So we're already much better in terms of performance, right? So we just need to utilize all this hardware. And I wonder at what requests this would break down. Of course, different setups, different startups would use different things, but this is huge machines, right? This is huge. And you have 3 servers like that, and until you exhaust that, and even if your startup fails, right, you can then sell these at, I don't know, a little cheaper and recoup most of that cost, right? So this is my super cheapskate hardware guide / rant about cloud and why I don't like cloud. So yeah, so hope this has been informational for you. If you have your ideas or objections, how this setup might fail, what's bad about it or something, or feedback, feel free to leave in a comment. I'd like to hear that, and of course feel free to like and subscribe. So this has been David from TrivialSolutions.io. I'm signing out. Peace.